Welcome to Mysteries of the Universe. I'm your host, Ben Carter. In the realm of the unfathomably small, beyond atoms and subatomic particles, where even the rules of quantum mechanics start to blur, lies the Planck scale. This is a domain of the universe where our understanding of the physical world doesn't just falter, it collapses entirely. It's a stage where gravity and quantum forces intertwine in a dance so complex that we are left watching from the wings, struggling to comprehend the performance. The Planck scale is an arena of extremes, a realm of the ultra-tiny where the fabric of reality itself seems to be woven from strange, unknown threads. This is not merely the world of quantum mechanics, but something far more bizarre, far more enigmatic. Named after the German physicist Max Planck, who first proposed the idea of quantized energy levels, the Planck scale represents the smallest possible divisions of space and time, a threshold beyond which the very concepts of size and duration cease to have any meaning. To enter the Planck scale is to venture into a world where ordinary notions of geometry are twisted beyond recognition. Imagine a cosmic tapestry where every thread is a curling, twisting strand of space-time, each one a universe unto itself. This is a world where the fundamental building blocks of reality are not particles or even strings, but tiny, vibrating loops of space and time. In this realm, the linear progression of time as we understand it is replaced by a chaotic, quantum foam of probabilities where past, present, and future exist simultaneously. The pillars of Einstein's theory of relativity crumble, and the deterministic laws of physics dissolve into a sea of random quantum fluctuations. Yet, despite its strangeness and its challenges to our understanding, the Planck scale may hold the key to unifying the disparate realms of quantum mechanics and general relativity, the two great pillars of 20th century physics. This elusive theory of everything would provide a unified description of the cosmos, from the smallest quantum particle to the vast, swirling galaxies. Though we have yet to decipher the peculiar language of the Planck scale, its whispers echo through the cosmos, hinting at a deeper understanding of the universe. Perhaps one day, we will crack the code and reveal the secrets hidden in this mysterious realm, secrets that could redefine our comprehension of existence itself. In the meantime, the Planck scale remains a tantalizing frontier, a realm where physics and the unknown collide, where the familiar dissolves into the strange, and where every discovery promises to revolutionize our understanding of reality. This is the edge of the known universe, the final frontier of scientific inquiry, a place where every step we take is a plunge into the unknown. The Planck scale, a cosmic enigma, waiting to be unraveled. The Planck scale, as we know it today, was first conceptualized by Max Planck, the father of quantum theory, in the early 20th century. As an attempt to reconcile the incompatible descriptions of the cosmos offered by quantum mechanics and general relativity, Planck proposed a set of natural units, now known as Planck units. These units, defined using only the fundamental constants of nature, the speed of light, the gravitational constant, and the Planck constant, represent the smallest meaningful measures of time, length, mass, and temperature. In this realm, length shrinks to the Planck length, roughly 1.6 pi by 10 to 35 meters, a scale so infinitesimal it defies comprehension. To offer some perspective, if a particle of the Planck length were to be magnified to the size of a grain of sand, the subatomic particles we are currently able to probe would be the size of the observable universe in comparison. Likewise, the Planck time, the time it takes for light to travel a Planck length, is about 5.39 × 10⁻⁴ seconds. This is the smallest meaningful measure of time, a temporal realm where the rules of classical physics give way to quantum uncertainty. Planck's proposal was revolutionary. It suggested a fundamental limit to the universe, an uncharted territory where our understanding of physics breaks down. It was a daring leap into the unknown, a theoretical construct that defied verification with the experimental tools available at the time. However, it wasn't until the advent of string theory in the late 20th century that the significance of the Planck scale truly emerged. String theory, with its extra dimensions and vibrating strings of energy, provided a framework in which the Planck scale could be more than just an abstract theoretical limit. It suggested that the Planck scale might be the stage on which the ultimate theory of everything plays out, the minuscule arena where gravity and quantum mechanics could finally be reconciled. From ancient philosophers pondering the nature of the cosmos to modern physicists probing the boundaries of reality, humanity's quest for understanding has led us to the edge of the known universe. The enigmatic Planck scale, a frontier as tantalizing as it is elusive, stands as a testament to this unending pursuit of knowledge. As we delve deeper into this realm, seeking to unravel its mysteries, we tread a path paved with the footsteps of those who dared to question, to explore, and to dream. This is the story of the Planck scale, a journey into the heart of the universe where physics and the unknown collide. The origins of our understanding of the Planck scale, like many scientific breakthroughs, can be traced back to the earliest human civilizations. Ancient cultures, from the Babylonians to the Egyptians, recognized the existence of a microcosm within the macrocosm, a world within a world. This understanding was often expressed through mythology and cosmology, with stories and symbols representing a universe that was infinitely divisible, reflecting the belief in an underlying order to the cosmos. The Greeks, led by thinkers like Democritus and Leucippus, furthered this concept with the idea of the atom, an indivisible unit that formed the basis of all matter. This concept was theoretical and philosophical, lacking the scientific underpinning that we have today, but it laid the groundwork for a deeper understanding of the universe at its most fundamental level. Fast forward to the 20th century, the era of quantum mechanics and relativity, when the German physicist Max Planck made his revolutionary proposal. He suggested that there was a fundamental limit to the universe, a scale so small that the classical laws of physics no longer applied. This concept, known as the Planck scale, was a radical departure from the continuous, infinitely divisible universe of classical physics. It suggested that the universe was, at its core, made up of discrete, indivisible units. Planck's proposal was met with skepticism and incredulity, yet it sparked a revolution in theoretical physics. The concept of the Planck scale served as a catalyst for the development of quantum mechanics, a theory that describes the behavior of particles at the smallest scales. Quantum mechanics, with its inherent uncertainty and bizarre phenomena like superposition and entanglement, was a far cry from the deterministic universe of classical physics. Yet it offered a tantalizing glimpse into the fundamental nature of the universe, a window into the Planck scale. The advent of string theory in the late 20th century further illuminated the mysteries of the Planck scale. This groundbreaking theory, which posits that the fundamental constituents of matter are not particles, but tiny vibrating strings of energy, suggested that the Planck scale might be the stage on which the ultimate theory of everything plays out. As we delve deeper into the mysteries of the Planck scale, we follow in the footsteps of those who dared to dream, to question, and to explore. From the ancient philosophers to the modern physicists, the quest for understanding the universe at its most fundamental level continues. The Planck scale, a frontier as tantalizing as it is elusive, remains at the heart of this pursuit. It is a testament to the unending human curiosity, a symbol of our quest to decode the universe and uncover the secrets it holds. As we delve deeper into the heart of the Planck scale, it's important to recognize the key figures and groundbreaking discoveries that have shaped our understanding of this elusive frontier. At the forefront of the 20th century's quantum revolution was Niels Bohr, a Danish physicist whose work on atomic structure and quantum theory earned him a Nobel Prize. Bohr proposed that electrons could only occupy specific energy levels, a concept that defied the continuous, infinitely divisible universe of classical physics. This quantum leap was a pioneering step towards understanding the discrete nature of the universe at the Planck scale. Werner Heisenberg, another luminary of quantum mechanics, introduced a level of uncertainty to our understanding of the universe. His uncertainty principle stated that one cannot simultaneously know the precise position and momentum of a particle. This fundamental uncertainty, inherent in the quantum realm, is a crucial aspect of the Planck scale, where precise measurements of space and time become increasingly elusive. Fast forward to the late 20th century, when string theory began to gain traction. The architects of this groundbreaking theory were physicists Leonard Susskind, Holger Beck-Nielsen, and Yoichiro Nambu. They proposed that the fundamental constituents of matter were not particles, but tiny, one-dimensional strings of energy. This theory illuminated the Planck scale in a new light, suggesting that it might be the stage where these minuscule strings of energy vibrate and dance, giving rise to the universe we observe. However, string theory and the nature of the Planck scale are not without controversy. Critics argue that these theories remain untested and unproven, residing more in the realm of philosophy than empirical science. Yet these controversies serve to fuel the quest for understanding the universe at its most fundamental level, pushing the boundaries of our knowledge and exploring the unknown. The Planck scale is a testament to the daring visionaries who have sought to unravel the mysteries of the universe. From Bohr's quantum leap to Heisenberg's uncertainty, from the architects of string theory to the skeptics challenging its premises, each has played a pivotal role in shaping our understanding of this elusive frontier. As we continue this journey, we stand on the shoulders of these giants, peering into the unknown and seeking answers to the fundamental questions of existence. The Planck scale, a realm where physics and the unknown collide, remains a tantalizing mystery, a frontier yet to be fully explored. The secrets it holds promise to unlock a deeper understanding of the universe and our place within it. As we delve deeper into the mysteries of the Planck scale, we encounter a host of anomalies and unexplained phenomena that challenge our accepted understanding of science. These enigmas, cloaked in the shroud of the unknown, serve to underscore the vastness of our cosmic ignorance while simultaneously fueling our relentless pursuit of knowledge. One of the most peculiar phenomena occurring at the Planck scale is the concept of quantum foam. Proposed by physicist John Wheeler, this theory suggests that space-time at the Planck scale is not smooth, as predicted by Einstein's theory of general relativity, but rather it's a seething mass of bubbles and tunnels appearing and disappearing in a froth-like manner. This foam stems from the inherent uncertainty of the quantum realm, where particles and antiparticles spontaneously pop into and out of existence, creating a constantly fluctuating, foamy texture to space-time. In stark contrast to our everyday experience of a stable, predictable universe, this concept of a chaotic, fluctuating Planck-scale universe defies our conventional understanding of reality. Yet, the quantum foam hypothesis remains unproven, as it lies beyond the current reach of our observational capabilities. This brings us to another conundrum: the issue of cosmic censorship. Coined by physicist Roger Penrose, the cosmic censorship hypothesis suggests that singularities, points of infinite density predicted by Einstein's equations, are always hidden within black holes, thus censored from the rest of the universe. However, quantum mechanics predicts the existence of naked singularities, which are not confined within black holes. If these exist, they would wreak havoc on our understanding of physics, as they are regions where our laws of physics would break down completely. The search for naked singularities, therefore, becomes a quest for the unknown, a journey into the heart of the Planck scale, where our conventional physics may not hold true. Finally, we face the mystery of quantum entanglement, a phenomenon that Einstein famously dismissed as spooky action at a distance. This refers to the inexplicable way that particles can become entangled, such that the state of one particle instantaneously affects the state of the other, regardless of distance. This defies our understanding of the speed of light as the ultimate speed limit, adding another layer of complexity to our understanding of the quantum realm and the Planck scale. These anomalies and unexplained phenomena serve as reminders of the enigmatic nature of the Planck scale, a realm that challenges our accepted understanding of reality and invites us to rethink what we know about the universe. The mysteries of the Planck scale, as profound as they are, have given rise to several competing theories in an attempt to reconcile quantum mechanics with Einstein's theory of relativity. One such theory is string theory, which posits that the fundamental particles we observe are not zero-dimensional points, but one-dimensional strings vibrating in a multidimensional space-time. In this radical view, the universe is a symphony of vibrating strings, and the laws of physics are the harmonies of their vibrations. The Planck scale, in this interpretation, becomes a stage for these strings, a realm where the melody of the universe is composed. Yet, string theory is not the only melody being played. On another stage, a different tune echoes: loop quantum gravity. This theory suggests that space-time itself is quantized, existing in discrete, indivisible units called loops. These loops weave a quantum fabric of space-time at the Planck scale, replacing the smooth continuum proposed by Einstein's theory. Both string theory and loop quantum gravity offer intriguing perspectives, yet neither has been definitively proven or universally accepted. This cosmic debate, this battle of theories, underscores the profound philosophical implications of the Planck scale. If string theory is correct, then the universe is essentially a grand cosmic orchestra, with each string playing its part in the symphony of existence. If loop quantum gravity holds true, then the universe is a woven tapestry of quantum loops, each a fundamental stitch in the fabric of reality. But what if neither is correct, or both are? What if our reality is both a symphony and a tapestry, or something else entirely? These questions plunge us into the depths of metaphysics and epistemology. They force us to confront the nature of reality and our knowledge of it. Is reality a construct of our perceptions, shaped by the limitations of our observational tools, or does it exist independently of our understanding? Is the universe as it appears to us, or are we confined to the shadows, forever chasing the elusive light of truth? As we delve into the Planck scale, these philosophical quandaries become inseparable from the scientific pursuit. The frontier of physics becomes a frontier of thought, where the known and the unknown collide, raising profound questions about the nature of existence and the fabric of reality. The Planck scale, it seems, is not just a realm of physical extremes, but a crucible for the most profound cosmic debates and the deepest philosophical inquiries. As we grapple with these theoretical uncertainties, it's fascinating to consider how ancient civilizations approached similar metaphysical mysteries. They too sought to understand the nature of reality, the structure of the universe, and the fundamental principles that govern existence. Ancient Egyptian cosmology, for instance, depicted the universe as a vast, infinite ocean known as Nun. This ocean was not simply water, but represented the primordial chaos from which everything emerged. This is remarkably akin to the theoretical models of quantum foam, a turbulent sea of fluctuating energy at the Planck scale. Just as the Egyptians believed that their gods brought order from the chaos of Nun, so too do modern physicists seek to find order in the quantum chaos of the Planck scale. In the East, the ancient Vedic texts of India describe the universe as an infinite cosmic egg, or Brahmanda, composed of concentric layers of elemental realities enveloping a central divine source. This notion of layered realities echoes the concept of multidimensional space in string theory. And let's not forget the ancient Greeks, who posited the existence of indivisible, eternal particles they called atomos. This concept, millennia ahead of its time, foreshadows our modern understanding of quantum particles. Then there's the indigenous Australian dreamtime, a complex system of beliefs that time is not linear but layered, with the past, present, and future existing simultaneously. This aligns strikingly with the idea of quantum superposition, where particles can exist in multiple states at once until observed. These ancient cosmologies, while metaphorical and mythological, reveal an intuitive grasp of the universe that aligns with our most advanced scientific theories. They mirror our contemporary quest to decipher the enigma of the Planck scale, reflecting the same yearning to comprehend the nature of existence, the structure of reality, and the cosmic order. Through their myths and symbols, our ancestors grappled with the same profound questions that we now pose at the precipice of the Planck scale. Their ancient wisdom reminds us that our search for understanding is a timeless human endeavor, a philosophical journey as much as a scientific expedition. And as we delve deeper into the quantum abyss, we may find that their ancient insights illuminate our path, offering echoes of truth in their mythic interpretations of the universe. As our understanding of the universe evolves, so too does our technology. Today, we employ tools that our ancestors could only have dreamt of, probing the universe's deepest mysteries. Telescopes, satellites, and space missions have become our eyes and ears in the cosmic expanse, revealing a universe more complex and beautiful than we ever imagined. These instruments provide us with a glimpse into the Planck scale, wherein the laws of physics as we know them cease to apply and a new, strange order emerges. The Hubble Space Telescope, for example, has been instrumental in our understanding of the universe's expansion. by observing distant supernovae, scientists were able to determine that the universe is expanding at an accelerating rate, defying our previous understanding of gravity. This unexpected finding led to the concept of dark energy, an unknown force that comprises roughly 68% of the universe and seems to counteract gravity's pull. Meanwhile, the Large Hadron Collider, the world's largest and most powerful particle accelerator, has been smashing particles together at near-light speeds. It was here that the elusive Higgs boson, often referred to as the God particle, was discovered. This particle provides other particles with mass, a fundamental property of matter. Its discovery was a significant step in our understanding of the universe's underlying structure. Even as these instruments reveal new layers of reality, they also deepen the mysteries of the Planck scale. For instance, the discovery of quantum entanglement, where particles become interconnected regardless of distance, has baffled scientists. It defies the speed limit set by the speed of light, a basic tenet of Einstein's theory of relativity. Satellites like the Planck Observatory probe the cosmic microwave background radiation, the oldest light in the universe. This radiation is a remnant of the universe's infancy, a cosmic baby picture that provides clues about the early cosmos and the Big Bang. Yet, it also hints at a hidden order that we are yet to fully comprehend. In essence, modern technology has allowed us to probe the universe's hidden depths, revealing a complex tapestry that intertwines the realm of the incredibly large with the realm of the infinitesimally small. These findings suggest an underlying order that defies our current understanding, a puzzle that we are still piecing together. As we continue this daring cosmic voyage, we may find that the Planck scale, the final frontier of the known universe, holds the key to unlocking the deepest secrets of the cosmos. As we delve deeper into the implications of these scientific discoveries, they have the potential to profoundly reshape our understanding of life, creation, and our place in the cosmos. The Planck scale, as a realm where the quantifiable and the abstract intersect, challenges the very foundations of our perceived reality. It forces us to question, what if our universe is not the grand expanse we envisioned, but rather a minute speck within an unfathomably larger multiverse? What if our existence is not a singular event, but one of many in an endless cycle of cosmic births and deaths? These questions blend the lines between science and philosophy, pushing us to reconsider what we regard as reality. From a quantum perspective, the world is a complex web of probabilities, constantly shifting and changing. The Planck scale, therefore, could represent a microscopic canvas on which the universe paints its grand design, moment by moment, decision by decision. The implications of this extend even to our understanding of consciousness. From the quantum entanglement phenomenon, we learn that particles can become interconnected irrespective of the distance between them. Could this principle be applied to human consciousness? Could our minds, too, be entangled at some fundamental level, hinting at a collective consciousness that transcends the physical limits of our brains? Moreover, the discovery of the Higgs boson, the particle that imparts mass to other particles, poses existential questions. If mass, a fundamental property of matter, is not inherent but bestowed, could the same be true for consciousness? Is consciousness a fundamental aspect of reality, independent of physical form, awaiting an appropriate medium to manifest? These are mind-boggling propositions that take us to the threshold of the known and the unknown, where physics and metaphysics merge. They suggest a cosmic narrative that is far more intricate and interconnected than our current understanding allows. In this context, the Planck scale represents a boundary, not just of physical size, but of human understanding. It is a frontier where our empirical knowledge grapples with the unfathomable, where the known universe dissolves into the shadows of the unknown. The pursuit of unraveling the mysteries of the Planck scale is not just a scientific endeavor, it is a philosophical quest that demands a re-evaluation of our place in the cosmos, our understanding of life, and the very nature of consciousness itself. To contemplate the Planck scale is to peer into the abyss of the cosmos, to glimpse the intricate weave of reality that binds every atom, every photon, every thought. We stand at the precipice of human understanding, looking out onto a universe that is both intimately familiar and profoundly mysterious. We are witnessing a cosmic drama, infinitely complex and breathtakingly beautiful, that unfolds in the grand theater of space and time. In the vast expanse of the cosmos, we are but specks of stardust, particles of consciousness carried on the cosmic winds. Yet our quest for knowledge, our insatiable curiosity, and our sheer will to understand propel us beyond the confines of our physical limitations. The universe may be indifferent to our existence, but we are not indifferent to the universe. We strive to understand, to explore, to learn, and in doing so, we assert our place in the cosmic order. The mysteries of the Planck scale remind us of our humble origins and our cosmic insignificance, yet they also illuminate our unique role in the universe. They challenge us to question, to ponder, to dream. They prompt us to seek answers, not just in the observable world, but within the depths of our minds, our hearts, our spirits. They invite us to embark on a quest not just for scientific truth, but for cosmic wisdom. As we probe the enigmatic realm of the Planck scale, we are not merely observing the universe, we are participating in its unfolding narrative. We are not passive spectators of the cosmic drama, but active participants in the grand odyssey of discovery. Each question we ask, each answer we seek, each revelation we uncover is a testament to our indomitable spirit, our relentless pursuit of truth, our unwavering commitment to illuminate the cosmic darkness. The Planck scale represents the edge of the known universe, the boundary where empirical knowledge dissolves into philosophical speculation, where science converges with the metaphysical. It is a frontier not just of size, but of comprehension, a threshold where the tangible meets the intangible, where the known confronts the unknown. As we journey towards this frontier, let us remember that the quest for understanding is not just a scientific endeavor, but a cosmic pilgrimage. It is an exploration not just of the universe outside, but also the universe within. It is a journey not just through space and time, but through consciousness and perception, through the intricacies of the mind and the mysteries of the soul. So, as we stand on the brink of the unknown, let us marvel at the astonishing complexity of the cosmos, at the profound mystery of existence, at the breathtaking beauty of the universe. Let us celebrate the vastness of our ignorance, the depth of our curiosity, the resilience of our spirit. For in the end, it is not the answers we find, but the questions we ask, that define our cosmic journey. Thanks for listening. This has been Mysteries of the Universe. If you enjoyed today's episode, be sure to follow us wherever you listen to podcasts, and if you'd like to support the show, subscribe to the Forbidden Knowledge Network on Patreon. Subscribe now.